A couple of weeks ago, I received the SO100, an open source robot arm from Hugging Face. And the nice thing about this is that people can just print this with a 3D printer themselves and build this demo on their own. But I received the assembled version. And then I was using LeRobot for the first time, which is also from Hugging Face. It's a Python library that you can use to control your robot arm. And it's super easy to use with nice functions that are easy to understand. And even if you have never done anything robotics like myself, it's very good to get started. But there was one problem because it's written in Python and I'm a TypeScript developer. So I created a project called LeRobot.js. And the purpose of LeRobotjs is to have a very similar API to what people have used already in LeRobot. So for example, you have find the actual device that is connected over USB to your computer. You have calibrate to calibrate the motor so you can know the range of each motor. And you have teleoperate to actually control the robot with some kind of device, for example, a keyboard. And the first thing that we created is called LeRobot Web, which is a package that allows you to control your robot directly from the browser. A Node version of this is coming very soon. It's almost ready, but not released yet. So let's see how this is working in our interactive demo. You can click on Add Unit here, then connect to this web serial, and then another one for web USB. Then you can define the name here, also the type. Right now I have an SO100 follower, so I leave it like this, and now my arm is connected, which is pretty awesome. And we use Web Serial API here to be able to directly send commands over serial to the motors to control them or to read their position. And we use Web USB to actually get a serial number, because otherwise we could not identify if we have multiple arms connected, which arm is which. And this is why we need Web USB at the same time. So what can we do now? We have the robot arm edit here. The first thing you need to do is to actually calibrate. So click on Calibrate, Start Calibration. What this will do is release the motor so that they are not blocked and you can use them. And then this dialog tells you to put the robot arm into the home position, the neutral position. That's what I'm doing now. And when you have it in the home position, we can click on Start Calibration. And now it will actually read the motor positions. This is how the home position looks like. And now, because we are in the home position, we can now move our robot arm into the positions that it should be able to move later on. So we're going into every direction here with every motor so that we then can use this motor in this kind of position later on when we control the robot. We do this very gently so that we don't destroy anything. Move every motor till the fullest of its range, which is way easier if you don't have a camera in one hand and do one hand to control. But anyway, like this. You open this one here, and we close it again and put it into the sleeping position. And then we have actually calibrated our arm. It's awesome. Let's go back to the dashboard. And now we can click on Control. And this will now help us to actually operate the arm using our keyboard. So we click on Control Robot. Now we're connected. And now we can actually move the robot arm, for example, with our keyboard. And also move it to the left, to the right, any position that we want. It's now doable. Can also open the gripper and close it. And so we can also use the user interface here. We don't need to actually have a keyboard. Then we can stop the control and then go back to a dashboard. And this is what you can do currently with this library. So the next step is to actually also include the leader arm as a tail operator, so we can use the leader arm to control the follower arm, and then also add records, replay, train, and eval here, so that we can record the data set, replay it, we start the training, and then we can also do inference. I'm not sure yet how this will work out, but I envision that we can use Omics from Microsoft here to actually do the machine learning part directly in the browser. And if you want to help me out with some hardware, it would be nice if you would give me access to this so that I can add this to LeRobot and provide some art here. And thank you for Paterbot for sponsoring the SO100, so I could get started with this, which was really awesome. You can find me on the LeRobot Discord as NerdDisco. And if you already directly know how this can be done, you can also directly find this code LeRobot.js on GitHub. It's open source under Apache 2.0, so anyone is welcome to help out and make this the go-to thing for people wanting to control robots directly in the browser. So, thank you very much.